Hi everyone, in this video I'm going to talk about NVIDIA Transformer Engine and how it supports specialized tensor operations for large language models. So first, what are large language models? LLMs are deep learning models trained on massive datasets. They can recognize, summarize, translate, predict and generate content. Popular examples include GPT and Llama. What makes them powerful is that a single model can support many kinds of tasks instead of being built for just one purpose. This is exactly why LLMs matter so much today. They help with writing, coding, summarization, translation, and chatbot applications. They also improve productivity and support creativity. In simple terms, they are becoming a general purpose AI tool that can be used across many industries. LLMs are also called foundational models because they can handle many tasks without task-specific retraining every single time. This is where ideas like zero-shot, one-shot and few-shot learning comes in. Basically, the model can solve tasks with no examples, one example or just a few examples. That flexibility is one of the biggest reasons these models are so valuable. Most modern LLMs are built on transformer architecture. Transformers are designed to understand relationships in sequential data, especially language. Instead of looking at words one by one, they learn how words relate to each other in context, which is what helps them generate more meaningful responses. Two key ideas that make transformers so well are: the first one is positional encoding, which tells the model the order of words. The second is self-attention, which helps the model focus on the most relevant parts of the input. Together, this helps the model understand not just individual words, but the meaning created by the whole sequence. Inside a transformer block, there are three main layers: self-attention, feed-forward, and normalization. Self-attention captures relationships between tokens. Feed-forward layer processes those representations further, and normalization helps stabilize training. These layers work together repeatedly across the model, which is why transformer computation becomes very large at scale. This brings us to NVIDIA Transformer Engine. NVIDIA developed it specifically for transformer-based models running on large GPU systems. Its main role is to optimize tensor operations at both the hardware and software level, so the heavy computations inside LLMs can run faster and more efficiently. It works closely with hardware such as the NVIDIA H100 and A100 GPUs. These GPUs are designed for high-performance AI workloads and help maximize parallel throughput. In other words, they provide the computing power needed to train and run modern LLMs more effectively. Now, one of the biggest challenges in modern LLMs is scale. These models have billions of parameters and require massive matrix multiplications. Traditional computation methods become too slow and inefficient. This is especially clear in attention operations where a lot of repeated computation happens. This is why optimization techniques such as caching are important because they reduce repeated work and improve efficiency. But solving this problem is not only about having a faster chip. Training massive models also needs hardware-aware design. Performance depends on scalability and throughput, not just model accuracy. So, for very large LLMs, distributed training becomes necessary. One important strategy for that is 3D parallelism. This means scaling training across multiple dimensions so the workload can be shared more effectively across many GPUs and nodes. It is one of the key ideas behind training very large language models in practice. There are three main forms of parallelism involved here. Data parallelism copies the same model across multiple devices but uses different data shards. Modern model parallelism splits the model itself across devices, and pipeline parallelism overlaps different stages of training. Together, these approaches make large-scale LLM training possible. Even though LLMs are powerful on their own, they can also be customized for specific tasks. Common approaches include prompt tuning, fine-tuning, and adapters. These methods help improve performance for specialized use cases without always training a new model completely from scratch. NVIDIA also supports this ecosystem through tools such as NeMo, BioNeMo, Picasso, and the NeMo framework. So overall, the main takeaway is that NVIDIA Transformer Engine helps make LLM training and inference faster, more scalable, and more practical for real-world AI applications. Thank you for watching.